Each year, roughly 2 billion low-tech pencils are sold in the US, and 14 billion are sold worldwide. So how do they do it?
Pencil. The journey of a pencil begins with the procurement of essential raw material. The primary components of a pencil are
Graphite, a naturally occurring form of carbon, is extracted from mines worldwide.
The highest quality graphite, known as vein graphite, comes from Sri Lanka and Madagascar. Simultaneously, the clay
is from deposits and quarries. This clay is crucial in determining the pencil's hardness and the darkness of the lead.
In addition to graphite and clay, wood plays a pivotal role in pencil construction.
The most commonly used wood is cedar. More specifically, California cedar, the choice wood for many years.
Cedar has a pleasant odor, does not warp or lose its shape, and is readily available. Gently wet. Pencil manufacturers often rely on sustainable forestry practices to ensure the responsible sourcing of wood.
First, the graphite and clay are ground into fine powders separately. The ratio of graphite to clay determines the pencil's lead hardness, with higher graphite content producing softer leads, and vice versa. Next, the powdered graphite and clay are mixed together with water to form a homogeneous paste. The paste undergoes a refining process to ensure uniformity. The mixture is then extruded through a machine to shape it into long, thin rods. These rods are cut into lengths corresponding to the pencil's final size. The process of mixing graphite with clay can be traced back to a chemist named Nicolas Jacques Conté.
Interestingly, his discovery came as a result of the graphite shortage in the late 18th century.
Conté discovered that when powdered graphite, powdered clay, and water were mixed, molded, and baked, the finished product wrote as smoothly as pure graphite.
The invention was so revolutionary that it's still used in pencil production to this date. The next step in pencil manufacturing is the encasing process, where the prepared graphite cores are encased in wooden slats. These slats are typically made from cedar wood. The cedar usually arrives at the factory, already dried, stained, and waxed to prevent warping.
Logs are then sawed into narrow strips called slats. These are about 7.25 inches long,
0.25 inches thick, and 2.75 inches wide. The slats are then placed into a feeder and dropped one by one
onto a conveyor belt, which moves them along at a constant rate. One by one, the slats pass under a giant cutting wheel.
This wheel carves grooves into the slats that will become the channel in the middle that holds the lead. Continuing along the conveyor belt, half of the slats are coated with a layer of glue, and the cut graphite is laid in the grooves of these slats. The slats without glue and without graphite in the grooves are placed on another belt that carries them to a machine that picks them up and turns them over. The two conveyor belts then meet, and each unglued slat is placed over a slat with glue and graphite, forming a sandwich. After the sandwiches have been removed from the conveyor belt, they are placed into a metal clamp and squeezed by a hydraulic press and left clamped together until the glue is dried. Once bonded, the pencils go through shaping machines.
These machines cut the pencil slats into their iconic hexagonal shape, which is the most popular due to its ergonomic design
And resistance to rolling off surfaces. This is done in two steps. First, the upper cutter of the machine forms three sides on top.
Then its lower cutter shapes three sides on the bottom. As soon as the bottom sides form, the pencils separate.
After shaping, the pencils undergo sanding to smoothen their surfaces. This step helps to remove any imperfections
and provides a comfortable grip for users. The pencils are then coated with a protective layer to improve durability and appearance.
A lacquer or enamel coating is applied, and the pencils are dried and polished to achieve a smooth finish.
Sometimes pencils may receive additional treatments, such as a heat treatment to enhance their strength and resistance to breakage.
Many pencils come equipped with erasers at one end, making them versatile tools for writing and correcting mistakes.
The erasers are typically made of synthetic rubber. The idea of attaching an eraser to a pencil is traced to Hyman W. Lipman,
An American whose 1858 U.S. patent was bought by Joseph Rechendorfer in 1872 for a reported $100,000.
The process of making an eraser starts with putting a batch of rubber into a mill.
The rubber passes repeatedly between large heated rollers. Additives including pigments, fillers, and vulcanizing agents mixture is blended thoroughly to ensure uniform distribution of the ingredients. Vulcanization is a critical process in eraser manufacturing. It typically occurs in specialized machines known as vulcanization presses. These machines are designed to apply heat and pressure to the rubber compound, allowing the cross-linking of polymer chains,
transforming the raw rubber material into a more durable and resilient form. Vulcanization also helps make the rubber more effective in erasing.
To make plugs which will be attached to the pencils, an extrusion process is usually used. The mixture is forced through a die
to form a long cylinder. The cylinder is repeatedly cut as it emerges, forming plugs.
To attach the eraser, a ferrule is inserted at the opposite end of the eraser, and the assembly is fixed onto the pencil.
This process may involve some automated steps, but certain pencils are still assembled manually.
Pencils are often initially packaged in bulk quantities for distribution to retailers, wholesalers, and stationery suppliers. Bulk packaging typically involves packing large quantities of pencils into sturdy cardboard boxes. The boxes are designed to accommodate various pencil sizes and can hold hundreds or even thousands of pencils.
For pencils intended for direct sale to consumers, retail packaging is used. Retail packaging typically includes individual pencil sets or packs.
The pencils are neatly arranged and secured inside a cardboard, plastic, or blister pack.
The packaging may also include branding, product information, and barcode labels for easy scanning.
Because they travel along a conveyor belt, pencils are thoroughly scrutinized before they're distributed to the public. Workers are trained to discard pencils that appear dysfunctional, and a select number are sharpened and tested when the process is complete.
A common problem is that the glue of the sandwiches sometimes don't adhere, but this nuisance is usually caught. Even with the world going electronic, the pencil industry continues to steadily grow.
The global market size sits at $15.95 billion, but experts predict the market will grow by 7% by